All right, it's the video you've been waiting for. It's solving the rest of the review. So please make sure that you're following along with me and you're showing your work, making corrections if necessary. Please don't wait and just write down the answers. Practicing the process will help you understand this math. So when we factor, we're looking for that greatest common factor. In this case, that's going to be 6. And when we factor, that greatest common factor goes outside the parentheses. Remember, it's like reverse distributive property. And then we divide each term by that common factor. That's what goes on the inside the parentheses. 30 divided by 6 is 5. And then we have the b. Minus 6 divided by 6 is 1. And we're left with c. So if you had minus 1c, that's fine. But 6 parentheses 5b minus c. Awesome way to check if you're correct is do distributive property, see if you end up where you started, and I do end up with 30b minus 6c. Letter B, not only do I have a 7 in common, but I also have an x in common. So now we're going to divide each term by 7 and x. My little x's are a little tough. So on the outside the parentheses, we have 7x. Negative 7 divided by a positive 7 is negative 1. X divided by x is 1, and then I'm left with a y. So negative 1y, or negative y, plus 21 divided by 7 is 3. And those x's, x divided by x is 1. So we're left with 7x minus 1y, or just minus y, plus 3. I could have also factored out a negative 7x, which would just leave me the opposite signs here, y minus 3. Either of these are fine. For number 12, this is one of those problems where I suggest starting with the answers and working your way toward the original problem. So let's see what is equivalent to negative 5x minus 15. Here I get negative 5x plus a negative 15, which is the same as negative 5x minus 15. Here I get a positive 5x, which is not good, so I'm just going to move on. Negative 5x minus 15, that one works. Negative 5x, now this would not be minus 15, that'd be minus a negative 15. If that's hard to see, change this subtraction sign into adding the opposite. So now I can clearly see that I have a negative 5 times a negative 3, which is positive 15. So that one does not work. And then the last one that gives me a positive 5x, so I can stop there. So the only ones that are equivalent are the first and third box. Sarah says 2 minus 5d is the same as 5d minus 2. Junior says that 2 minus 5d is the same as negative 5d plus 2. Who is correct and why? Junior is correct because, remember, we can change subtraction to adding the opposite. That keeps it equivalent. And now that it's addition, I can use commutative property and say negative 5d plus 2. It's a positive 2, so we can say plus 2. The problem with Sarah's response is that 2 minus 5d, well, subtraction is not commutative. So if I did change it to addition so I could move the order around, well, now it's a negative 5d. This is a positive 5d. This is a positive 2. This is a negative 2. Those are not equivalent. So notice how with juniors, the signs stayed the same. Minus 5d, negative 5d, positive 2, positive 2. So junior is correct. Number 14, we're going to distribute that negative through the parentheses. You could also think of that negative sign as the opposite of. So I'm going to take the opposite of everything in the parentheses. That negative 10 becomes a positive 10x. And that plus 3 becomes minus 3. And that's it. That's as far as we can take it. Number 15, we're going to distribute first because distributive property is multiplication. And technically, I multiply before I add. X times 3y gives me 3xy. We usually write those variables attached in alphabetical order. Minus 4 times x is 4x. And then we have that plus 8. We're not going to distribute the x to the 8 because it's not a part of the parentheses. And guess what? That's as far as we can take this. If you had it written in a different order, that's fine. You could have negative 4x plus 3xy plus 8. Just make sure the signs are correct. And we cannot combine any of those further because those are all unlike terms. For number 16, we're going to set up the expression for part A, and then for part B, we're going to solve it. For part A, here's my expression, $1.29 per pound of nails, N plus 79 cents per pound of washers, W, and $2.39 per pound of bolts. And we don't use the dollar sign in our expression. There's enough symbols going on. Next, we're going to evaluate. So for part B, they tell us how many pounds of nails, washers, and bolts. So I'm going to put those in the correct spot, and then I'm going to solve. When I write this using the numbers for the variables, when I evaluate, I'm going to substitute in 2, I'm going to substitute in 4, I'm going to substitute in 3 for their respective variables. And then I'm going to solve using order of operations. So that tells me I have to multiply each of these separately first and then add them together. I just want to point out here that it is not enough to just write it like this and leave it. You actually need to solve it to get one number as an answer. When I multiply these separately, I have my products here, and now we're going to add those all together to get the final cost. Altogether, we get $12.91. Make sure that we label it because it's asking us the total cost. Ooh, a little sound effect there. Number 17. Oh boy, love this one. Here we go. We're going to first, for part A, we're going to simplify, so we're going to combine like terms. Let's go ahead and use the commutative property to get our like terms next to each other and then go from there. Once you've done that, you can see it's already looking a lot more friendly. So let's start combining those like terms. Here I have positive 8b. And then I have 3c minus 15c. I'm taking away more than I have. If that confuses you, go ahead and change this to adding a negative 15c. 3c plus a negative 15c, those are different signs, so I subtract. I get 12, and there's more negatives than positives, so minus 12c or plus a negative 12c. And then here, if you're like, I don't know if that's positive 20 or negative 20, look at the sign in front of it, or change it to adding the opposite. So negative 20 plus 4 is negative 16. I can just put minus 16. Or plus a negative 16 is fine as well. So we combined our like terms and we were careful with the signs. For part B, we're going to factor the simplified part A. When I look at 8b, 12c, and 16, they all have a common factor not just of 2, but of 4. That's the greatest common factor. So then I'm going to divide each of these terms by 4 to get the inside of the parentheses. 8 divided by 4 is 2, and there's still a b. Minus 12 divided by 4 is 3, and there's a c. Minus 16 divided by 4 is 4. I'm going to check the numbers inside the parentheses just to make sure that was the greatest common factor. I have 2, 3, and 4. The greatest common factor of those is 1, so I know that I factored the greatest common factor. Woo! Last, we're going to evaluate b equals 2, c equals negative 3. I'm going to look, I can use any one of the expressions that I've had so far. I can use the one I started with. I could use the one where I combine the like terms. I could use the factored expression. For me, I kind of like this one here. And I'm going to substitute in 2 for b and negative 3 for c. I'm going to solve this using order of operations. Here I get 16 minus 12 times a negative 3 is a negative 36. I can't say, oh, well, I already have a negative sign here. No, that's this subtraction sign here. So I have to say minus a negative 36. I could have also up above just made this into adding a negative 12, and I could clearly see that I have a negative 12 times a negative 3, which is a positive 36. But we'll get there. And bring down the minus 16. Anytime I have a negative negative, that's the opposite of a negative 36, which is positive 36. When I add these together, it looks like I'm going to get 52 minus 16. Bring down that minus 16. And this is going to give me a positive 36. So the value of that entire expression is 36. Number 18, during a walkathon, Team A walks a total of 6x plus 12 miles. Team B walks a total of 4x minus 7 miles. What is the difference in miles walked between the two teams? You can picture these as different expressions. Here's the expression for Team A, expression for Team B. So we're going to subtract that entire second expression from the first. So I'm going to keep those parentheses there to show grouping. Here we have Team A. And again, we're subtracting it because we're finding the difference between the two. So A and B. We know that we have to distribute this negative through when we subtract. That's really important. So when I rewrite this, I'm going to get 6x plus 12 minus 4x, because that's a positive 4x. And when I distribute that negative, I get minus 4x plus 7. Opposite of a negative 7 is positive 7. From here, I combine like terms. I could do commutative property if I needed to, but I see a 6x and a minus 4x, which gives me a positive 2x. And then I have a positive 12 and a positive 7, which gives me positive 19. So I get 2x plus 19 is the difference in miles.